Hello everyone, and welcome to today's live stream, which is the finale for 2025. I was looking through this year, doing a nice little review and everything, and it has been quite a year. Though, yeah, a lot of Blender stuff has happened, a lot of cool additions, a lot of cool projects in the works and stuff like that. But it has been a pretty good year. So, for today's project, I'm going back to the basics. I was like, what would be a good project? And I was like, a particle system done from scratch. I've done so many of these, but then I turned it into assets that people could use. And I think the first particle system that I made, the first particle system kind of made of multiple nodes that were an asset, was made like maybe 2 years ago, the first iteration. And I've been using variants of that ever since. But I want to go and make one from scratch today. Just a simple snowball simulation where a particle gets thrown, hits the wall, scatters into like a billion smaller particles for the nice powdery snow, because we got snow over here in the northeast of the United States, and it was pretty cool. Alright, let me just check that the audio and everything is working. Yes, all that seems to be in order. Alright, let me make sure the stream... Okay, the stream is not unlisted, good. Alright, so let's get started. So this empty right here will be our particle launching point. It'll give us the velocity and the position for the starting particles. And then when they hit, I'll go and separate the particles with a bit of collision detection. And then those will scatter into children particles, which will basically do the same thing. And I also need to make sure that this doesn't happen too recursively, where the smaller particles hit and then duplicate and then duplicate and then duplicate. That would be quite funny. But let's get started. So let's go and get a simulation zone. Put this right over here. We have the delta time, which we will be using. I'm going to be doing this correctly. And then we will be using a join geometry node. And then we'll bring in our empty. And this empty, we'll set it to relative. And we will be using the location and rotation for a point in space, so just one point. We'll put this right into here for the position, and then we're going to store the velocity. So, let's just put the full name in there. We're going to be doing this right. Then we will rotate vector right here, and this vector will be, let's put it on the y-axis. So this will be our starting velocity. So right here, we just do that and that. We plug that into there, and now we have a particle that will be joined into the fold every single frame. Actually, new particles. There we go. But now, I need to go and make it so that these particles will actually move according to the velocity. So, before I made this, actually, did we join the particles last or first? That's one thing I've forgotten because I haven't done that in a while. But let's make it so that the particles will move with the velocity. So we're going to use a set position node, and then we'll use the velocity that we have right here, and then we will scale this by the delta time. Almost forgot that part. We will be using delta time this time around, and we'll just use that to offset the particles. So right now, the velocity will stay constant, but the particles will move and do all that. So now we have particles moving along in space, and if we rotate our empty, we can see that the particles move around as they should. So I'm going to make a nice little animation where our empty here just moves around so that we can easily test things to make sure everything is going as expected. And let's go and move that up to here. So yep, we can see that it is moving. Now, do we want particles to be added every single frame? Not really. We'll get to that. But let's go and add in gravity. So to add in gravity, we need to offset the velocity. So here, we will take the velocity, and then we will add a certain amount to it. So in this case, it should be 9.81 meters per second negative. That should give us the right gravity, I think. Though, is that too harsh? Wait a minute, I need to remember. Do I need to scale? Yes, I need to. Bear with me, it has been a while. We need to scale this by delta time. And then plug it into there because this is a force. So if we do that, we should see, yeah, that seems to be correct for gravity. 9.8 meters per second squared and all that good stuff. So here we have our velocity step. So I'm going to turn this into a nice node group for easy management. Whoops. For easy management. because we need that. We need that. And then we'll have our force be put into there. So now, if I go and do all this here, oh, we can just plug that into there and there as well, because it is the same value. As we can see, with a little bit of cleanup, we can see that it works quite well. And also I'll put in the velocity name into here so that we can edit it if need be. So this will be delta time, and that'll just be our, yeah, the vector. So here, does that look okay? Let's put the delta time above everything, just to make sure the lines are nice and straight. So this will be velocity step. I will read the comments soon. Let's see. How are you today? I'm doing good. I, unfortunately, am still sick, which is hilarious. But it is just filtering out of my system. So my voice might sound a little bit different, but that is par for the course for these days. So now we have our velocity step with gravity enabled. And there we go. So now we have all that. The particles are moving. But again, I want these particles to move every couple of frames, so we will use a switch node to disable this, except, actually, we want this to be true. So again, right here, nothing will fire until we do that, and then that'll happen. So to make sure that this is staggered, let's go and use the scene time frame, and then I will use a, let's see, should I use modulo? Or Lord modulo? Yeah, let's just use that. Before I would use wrap, but I'm like, wait a second, shouldn't a modulo be the right way to do this? So if that's equal to 0, that should work. Yes, that should work. So every 10 frames, again, 0, nothing happens, and then, yes, frame that, and then frame 20, yep. So every 10 frames, we get one of those there. So there we go. That is very, very good. Let's put that into a frame. Again, the lines and boxes. We love the lines and boxes here. So let's see. I could put this nice and vertical just so that we have that very nice right there. So this will be, let's see, fire rate. There we go. So we have the new particles, the fire rate, all that is handled. I feel like we need a bit more velocity because snowballs, when you throw them, yeah, are a bit more like that. But then again, I need to keep the scale of everything into account. So let me go and add in a human, just for scale. And reset the... Go, that'll be good. Reset all that. So this is the size of our human, which makes me realize that our little backdrop here is not nearly big enough. So here we go. So if the human is throwing the snowballs, 180, let's bring that over to here. We can see that that is going there. That's it. Let's also move the empties height to be a little more around chest level. So right here, just so that we have that be a little bit more accurate. So there we go. Boom, 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 boom. All that's firing as it should. I think let's slow down to 20 meters per second right there. Yeah, that seems to be good. So now, since we have our main simulation set up, we need to add in collision detection and then basically the fracturing of our snowball here. So let's see, how should I do this best way? So for collision detection, how do we do that? Well, collision detection is the most annoying part of geometry nodes, just off base. The one part where we just can't really do it fully well. Particles are the best case scenario for it. Anything else, it's just like, you technically could, but it would be slow as hell, and you probably shouldn't. Let me go and change this to sim, put it into its own collection. Oops, new collection, sim. Let's color that in green. The set will be blue. And then our floor object will be in another collection. This will be collision. Yeah, that'll work quite well. And then this will be our floor. There we go. Let's see. And then let's go to our sim, bring in our floor. Actually, let's bring in the collection right here. Separate children. Set this to be relative, realize instances. Now, setting it to relative doesn't really mean anything here because our geometry node simulation object is at 0, 0, completely zeroed out, so that's all good. but it's good to have that there in case I do move it. Okay, and for collision detection, I'm like, should I go and make it a node group just for simplicity's sake? Just to have that there and I don't need to worry about it? Or should I have the collection info outside and then do everything in there? We'll see. Did you get a new method for collision using SDFs or not yet? Not yet. Basically, I'll be doing what I normally do, which will be using a geometry proximity and a sample near surface, because for a accurate SDF calculation and all that, we need to get the normal, except this needs to be the normal on the point domain. This will be the most complicated step of this entire process. So, let's keep that in mind. Okay, so for the position, we need to subtract the current position from the target position. So here, that'll just give us the localized position, or the vector to the surface right here. And then, when we have that, we need to go and get the length from that point, and then we basically need to do a dot product. Actually, wait. I'm forgetting a critical thing here. Wait a minute. This should be fine. Let's see. Normalize. Then I should be able to just dot product here to get the distance outside or inside the mesh. Now, this will be using the normal to see if it's on this side or on that side. So, if I did this correctly, again, the dot product is like a distance along axis, where the normal will be our acting axis here. So, a few tips with geometry nodes. If you master the dot product, you will master everything. It is a very, very useful node, or just math operation, that allows you to do so much with collision detection. The separating axis theorem uses this a ton. Basically, everything uses this. A cross product, that's secretly a, it uses, wait, does it use dot products? Or it uses similar math to dot products and all that. Vector projection, rejection, reflection, and all that, it's all just dot product under the hood. And I could be a little wrong about that. It's been a while since I've looked up the internals behind that vector math. But with this, we should be able to tell the distance outside or inside. So let's go and get our viewer. Take a look at this. Attribute text. There we go. And it seems like this is inverted. So I need to go and do that. Wait, I thought that was the right way. Anyway. Or maybe, wait. Let's check the face orientation. Face orientation is correct. Okay, so I just had that the wrong way around. But with this, we should see right here that this is 1 meter outside, and on this side, it is -5 meters. So now we can detect, and I feel like I need to do a little bit more to make this correct, because it feels like this is a little bit off, but I'm not sure. Let's see. Let's go and nip that in the bud right there. Let's see. So we have all of that. Let's go and put this over to here. And that is our collision detection. So now we can tell how far inside or outside the mesh we are, and that will be used to tell, like, when that will occur. I feel like, wait, there's something else I need to do. Let's see. Just to verify this, I need to make sure. Right, we need to set the position of the particle. Okay. So with this, we need to actually apply our collision detection, which I should make this a node group. Yeah, let's just go and make this a node group. Okay. So here, we'll node, make group. This will be SDF collision. So SDF, or collection, collision. Yeah, that'll be good. And here, we will be using the collision one right there. So this will be our sign distance field. And then here will be the wait a second, which way does the normal need to be? Because this while it is the normal from there, that just tells us whether we're outside or inside the mesh. This one is the accurate normal that we need, right? I'm remembering what's going on. So here we need to normalize this, and this will be our normal. Should probably capitalize these. because it looks better. And because, you know, all the inputs and outputs normally do that. But this normal is not correct. If it'll just be pointing to the surface, so I need to multiply this by the sine of our distance. So we need to get the sine, there we go, and the sine is whether it's positive or negative, because again, signed distance field and all that. So we're basically undoing the normalized part here to get the normal. That I know it's confusing, but this will work. I just need to make sure that it's pointing the right direction, because I may need to use a negative, or should this be a multiply by -1? I forget which one is better. But let's go and take a look at this. So if I go and take the viewer and see this, we should see that correctly. Yep, that is 1. Yep, the normal there seems to be correct, and then that normal seems to be leaning towards, well, that's basically 0. So here, yep, that's correct. That is correct. Wow, I did that first try. How about that? Let's give this a little bit of extra space right here so that we can just, actually, no, that's fine. Put that into a frame and then that into a frame. So we don't even need that. Shouldn't you use normalized normal to set the sign? Shouldn't you use the absolute normal to set the sign manually? Let's see. It should be fine. Wait. The normalized normal. Set the sign manually. I'm not sure if I fully understand your question here. Make sure the SDF node group will not be part of the sim zone. Yeah, it probably won't. Here, while we're getting the normal from the surface, this is the smoothed normal, which is needed to, from my experience, to make the SDF watertight, because in some cases, or mostly watertight, in some cases, like when you're colliding with the cube, the edges will freak out, especially if you're far away from a corner on the outside. I've done this where I've had like a grid, and that, actually, yeah, that is a good example. Let's go and get a grid so that we can view these values, so that we can actually see what's going on, rather than me just telling you all, even though, Mod, you probably know more than me when it comes to this. So here, let's go and add in a cube to our collection here. Then let's go back to our sim. So this is just our collision detection thingy-mabopper. There we go. So here we can see right there, that's all good. But if I were to output just the flat normals, which let's just do that for, yeah, the true normals. If we go and output that, this can lead to float point precision issues, if I'm correct. Wow, okay. That's not freaking out at the moment. It is biasing towards one, it looks like it. I don't know, maybe I'm incorrect with this. Let's take a look at the difference. Okay, yeah, no, we can see the difference. With the true normal, it'll just snap to one or the other, while this will give us the normal. That'll give us the right direction for the collision. And then with the SDF, we can see here, uh-oh. Ah, no, this is what I was afraid of. So we can see here that our SDF is incorrect. Crap. Why are you incorrect? That should not be doing that there. Let's go and use a wrap. No, actually, no, fraction should work. I shouldn't do this for too long. 'Cause yeah, we're seeing something incorrect here. This, yeah, it's almost like the exact opposite of what it should be. Let's see. I'm actually going to go, so I don't disable the viewer. I'm going to pin this right here and then go into here. Ah, good. So that is constantly viewable right there. I'm just going to go and collapse that right there. So what's the problem here? Got the dot product going into there. If we just get the length and then sign it. Maybe that's what I need to do. Because I have a feeling that the normal there is causing some... Yeah, okay. So we'll be using the normalize simply to get the sign here, and then I'll be affecting the length. That's annoying, but... Well, apparently it's what we need to do. Okay, so multiply with the sign. Yeah, it's annoying, but we can see the difference here. This is simply to tell us which parts... The dot product here is simply for the sign. To tell us which parts are inside or outside. And then that's just going to be used for here to sign our distance field. Yeah, little annoying. Or I could just scale the vector and then get the length and do all that, which could be a little bit simpler, but... Would that be the best option? We could simplify this. Sorry that this is becoming a, oh, should we do this or should we do that kind of stream? But, yeah, it's fine. Here we go. So I'm going to scale this by the sign beforehand. Wait, no. I don't want to do that. Never mind. That wouldn't work because they're vectors and everything else. So forget everything else I just said. So this is our setup. It's a little bit annoying to have to set it up this way, but it works. It's what I found works. So there we go. Now we have an accurate distance from the mesh. We can see that's good. And an accurate normal. So those are the two things you need for a collision. Again, with this, I made a node group for it in my everyday node group asset pack. So just use that and forget about everything else. So with all that done... How long have I been streaming? Oh, 21 minutes. That's not the worst. Well, with all of this done, I'll be using the minimum, which this is choose the minimum. So this will say, hey, get the normal, and then get only the negative values for that. And then we will go and scale that by -1 so that we'll put the particles on the surface. So now, with the simulation, in theory, we can see that these parts are colliding. And they will never leave the mesh because of all this. Now, because... We'll keep that math external. We'll just keep that external for now. Except I can make this a little bit better by using just a empty subtract, 0 subtract to turn that into negative. And here we can see that's a little bit better. Though I'm going to put the normal up top and that right there so that it'll be a little bit cleaner. So that will do that, and that determines, yep, that is our collision. Now we won't need the full collision for this. My plan is to just detect if the SDF is negative and then freeze the particle. Though then again, I do want it to be set there, and it's fine. Okay. So, now's the somewhat complicated part. Okay, I feel like I'm losing steam a little bit because of the SDF stuff, which again, collisions are the most annoying part of all this. Shouldn't you be falling a bit more? Yeah, okay, you did fall a bit more. That's because the velocity is not reset. So, let's go and actually do some stuff with this. So, my plan here is if... but no, we want to keep the velocity. The main things that I want to do is detect if there is a hit. So this will be hit. Hit is true. Let's make that Boolean. That is less than 0. A hit will be detected. So maybe I should use a capture attribute node so that we just store this so that it doesn't have to recalculate twice, once for the named attribute, one for the set position. That is the that's one of the benefits of the capture attribute node versus the stored named attribute node. Since we can put multiple inputs into here, we can have this stuff calculate only as many times as it needs to, and then we can go and put it over into other stuff. But that's not the most important right now. So if the hit is set to true, we will do that, have that as a nice Boolean, and then we should see that, well, nothing's changed because I need to actually reset the velocity, which I will not keep, but just for demonstration's sake, we will have a vector, And then right here, this will just reset the velocity. Yeah, it doesn't reset the position, so it should be fine. So here we can see it hits, and then the velocity gets reset. Now, if you wanted to make a more proper, let's just take a look at the actual SDF collision setup I have right here. So this is the node group that I have, which allows for bounce and friction. Basically, it's a lot more math. This is kind of the condensed... Oh, I made this before the capture attribute node had multiple inputs. Lovely. This is old. But basically, you do a ton of math, getting the normal and the tangent impulse and all that, add it to the velocity and all that. And basically, just copy this if you want accurate collisions, or download the node group. But again, we're doing this from scratch. I will not be doing friction and sliding and all that. It will just be detect, split the particle into a billion pieces, run it one more time, and that'll be good. Okay, so that's that. So let's make a node group for our collision response. Actually, yeah, we'll store the... it's normal. We'll just put that into there. And of course, I put that... We don't really need the hit normal, but it's fine. Just for organization's sake, we're going to put that into there. And then, but that means I should store the SDF as... it's so fun. So fun. You love to see it. But yeah, that's... So I would need to sort... Yeah, we're making this a node group. Node... Make group. Or, wait a minute. Yeah, we'll just make this the response. So node, make group. Oh, it only made one value input into here. So this will be the normal. This will be SDF. So this will be collision response. Yeah. That's good. And then I could just, yeah, no, that's the way to do it. Okay. Now we have all of that. I can store the hit normal, or I can just use it, which in this case, I don't think we need to store it. I'm just going to have this into here. Try to keep it nice and organized. Eliminate you. All we need to know is if it actually hits and how much it does hit. And then based on that, we can go and mark this for the particle splitting, which will happen later. So again, right here, we have that happening. Again, we will want to set the velocity. Yeah, we do need the hit normal. Well, okay, we're getting sidetracked by the collision. The collision is the most annoying part of this. Okay, so with this, I want to split the particle. So how do we do this? Well, we will use the duplicate elements node. Or do I want to separate geometry? Which would be the best? Do we separate the parts and then do all the stuff and then join them? Yeah, no, that's the way to do it. Okay. We'll use a separate geometry node, because that's just the best way to do it. And one thing I will need to mention is that we will need a new value, and this will be just a value to say if it's the origin snowball. So here we'll do, what should we have this as? It should just be a boolean. This will be origin, or no, this will be, parent. Yes, the parent snowball. Or I could just mark the children. No. We'll just mark the parents and make that true. Then when they separate, I'll set the parent value to be false so that they cannot split again. This will be boolean, so we'll just need to know if a hit occurred. So this will be a boolean and. So did it hit, and is it a parent? And if so, split. And then it'll just go and split the particle into a billion little pieces. Give them some random velocity and all that. So we will need the duplicate elements node, and this will be a random value. This random value, we will use the scene time frame to randomize that. So it'll be between, 0 and 100. That seems to be a good amount. We'll plug that into there, but we need to reset the velocity value. This one will make this just random. Let's have this as a random value. Let's go and put this to be -1. Let me go and save this because I have not saved this file yet, and that's probably important to do. Do I normalize it? Nah, let's just get this working first. And then it'll send it through. So that is good. And then we join this back into there, and that should give us our... So I might have made a slight miscalculation. There is a hit. Oh, wait, I forgot to set the hit to be false. I think. Here is true. And hit. Yeah, no, hit is true. I need to set the hit to false, which... Now that should be false the next time they go into the fold. And also, maybe I should go and add a little bit to that, or subtract a little bit from the SDF, but I'll put that in the response, just so that we can move this a little... Oh yeah, I could just put that into there. So why do you split into a billion pieces right there before you're supposed to? That should only happen if you split. So here... I know that is... Oh! It's because I'm an idiot. It's because the selection goes into there, and the inverted goes up into there. So, the selection, that is... Why do I keep forgetting that? Anyway, let's just do a little thing where these parts will invert. Totally not confusing. That will not confuse me whatsoever in the future. But here we can see, now that those are reversed, we'll be fine. So here we can see, as soon as they hit, they turn into a billion particles, which is exactly as I intended. So now, the point will be, we can detect if it's apparent, we can detect all that. Let's go and put this into another node group right here. We're at 31 minutes, okay. Not the worst for building a particle system from scratch. Let's go and put this into here, and this will be, let's see, particle split. Did I put in 2 spaces there? I didn't. How did that happen? But there we go. So again, we have all the node groups for that, and now we have these set up. So again, making a particle system from scratch. So we have that, and I will want to set the radius to be a bit different. I could use the radius for the collisions, which actually may be a good idea. Not entirely sure. Also want to make sure that this is making the particles float above the surface. Yes, they are. Because this is a signed distance field, we can go and put the particles above or below the surface as much as we want. So we could plug in the radius into here if we so choose, which, yeah. Just go and use the... Or actually, no, we don't want to put that into there. What we want to do is... Ooh, I forget if the minimum will screw things up here. It probably won't. Yeah, no, okay, that's fine. We put in the point radius into there, we should see that, yes, these particles will not be colliding into there, and that'll be good. So with that, we have that. I'm still not sure if I want to keep that in there, but it should be fine. Let me read the chat because I've been neglecting all of it once again. Classic fashion. Let's also set the... No, chat first. Okay. Let's see. That's kind of huge to know about dot product. I felt the same about distance/length in the vector math node. Yes, distance and length do very similar stuff, just one has 2 vector inputs and the other one has 1, so you would just need to use a vector math subtract to get the same thing from each. But dot product is, again, the way my brain compartmentalizes it right now is just distance along axis. And it's basically, yeah, basically a length node, but along an axis. But it gets scaled by the input vector and all that fun stuff. But basically, dot products, it is just how everything works. You could use it to build your own 4x4 or to apply a 4x4 matrix and all that stuff, and it is great. Let's go and set the particle radius. Set point radius right there. I love inline geometry, sockets, and all that. Now, right now, all of these are using the same seed value, which may kick me in the rear down the line. So let me just go and... Let's see. I should set a... Okay. You're going to be that way? Okay, then you're just going to have that. There we go. We can collapse you. You'll be fine. I should make this spherical in the future, but for now it's okay. For this radius, I'll set this between 0.1 and 0.01 so that once they hit, we can see, yes, that is occurring. So let's make this a billion particles. So again, boom. There we go. And let's make these a lot smaller because I want it to at least seem like the particles have equal mass. So the snowballs are not just, no, that needs to be bigger. So the snowballs are not just disappearing or turning into something much larger than they should be. We'll have these as 0.2. That should be okay. So there we go. We have all that. We can see that the explosion is very square. I also need to make sure that when these hit, let's see what would happen if they do hit. I need to make sure that the velocity resets. That's something I should just do. I should also just store the SDF in normal as named attributes so that I don't have to do this kerfuffle over here. It's fine. Put that into there because if I don't store this beforehand, it'll keep recalculating every single gosh darn time, and I don't want it. Yeah, we're just gonna store it. So hit normal. And we will store the hit distance, but yeah. So this is just a little quirk of geometry nodes, and I could be wrong about this. Mod, if you're still here, please correct me with this. But if I connect all of these parts separately into here, it'll recalculate, in this case, twice. But if I capture it, it'll calculate it once, and then storing it will just store it for later use. So it would be technically better, or this will be hit distance or hit SDF. SDF, hit distance is easier to explain. We'll just have this so that we can just have the data in case I need to use it for the children. And also it just cleans up internals a little bit. We have that and that. Hit detection is stored. And that should be good. So that's all the data we need right there. Should be good. We're just storing everything so that we can use it later on. There we go. So that should be good for now. It could be twice as slow. Again, if I just use a capture, I'm just gonna do it. I'm just gonna use a capture attribute node so that it won't have to calculate the stuff twice, and all we'll have to do next is store it. I know this seems a bit stupid and quirky, but it's just a little efficiency step here. Yeah, actually, wait, I should go and show this off. So again, right here, we can see that just takes a millisecond, and that takes less because it's just storing it, while here, both of these take the same. So again, just doing this, a little efficiency step. There we go. So now with this, we can go and have some fun with the setup now, since we actually have it ready to go. So I will probably instance on these particles. Let's go and make the world a little bit brighter. There we go. We also need to reset the velocity. I forgot about that part. So again, the collision response. If it hits, we also have to hit normal, so that's fine. We don't need to worry about that. This will be resetting the velocity, which we may want the velocity for the children, but I think this is fine. We can just mark if it's a parent to not reset the velocity, and if it's a child to reset it. But it's okay. Excusez-moi. There we go. We can see here, yes. Goes and hits, and they do fall just because when they hit, they still... Actually, wait a minute. Oh, is it because they're technically not colliding? I could make it so that if they hit once, they'll just freeze and stop applying any velocity steps whatsoever. That could be the way to do it. Because it's like, oh, I hit, I didn't hit, I hit, I didn't hit, and it just moves down a little bit more. Causing a gradual slide, but, you know, that might be a bit more snow-like. And also, turn off temporal reprojection. Always, always turn that off. Every time. Never have that on. Never. Turn on ray tracing, turn off bilateral filter, and maybe temporal accumulation is probably fine there. I don't know why it works here, but well, temporal ray projection. It just makes everything blurry and terrible. You should never have that on if you're working with animations. It's only for the viewport as well, so you get a more accurate. That should not be on by default. But my annoyances with EV next aside, yeah, we have that here, and here we can see that the snowballs really do just disappear into a puff of smoke. Oh wait, why do they disappear and then appear the next frame? They should oh wait, no, I know why. It is because the snowballs start with a position of 0. So let's go and update the particle split to be a little bit better. So here we have our split part. Let's go and put this over to here, move it back a ton. We set the parent to be 0. Let's go and set the ID. So this is different than the index. This just needs to be, and I need to be careful about this because I don't think I can set a random value. I'm just going to set this to be the max. Change it to be a little bit less so that the integer doesn't overflow to being negative. This is just so that all of these have a random, unique integer value. Now, with this, there is always the chance that... Oh, wait, I should use... There's a hash value node just for this reason. I keep forgetting. We'll put the index into here just so that we can get a nice random hash. Please don't crash because I've set this to be negative before. Okay, good. So, hash the value so that we get a nice random hash. Why did I forget the hash value exists? I've used this node so much. So again, the index and the frame into there just so that we get that to be random. So all these down the line, we'll treat these as if these are random. So I guess that means I don't need to use you anymore. Just want to make sure that that is... Because it'll make sure that the ID is different for all of these. This is like a pseudo stored... It is a stored named attribute, but we cannot access it. It is a little bit... Wait, can we access it? I keep forgetting. Can we access the ID? And of course, because it is stored inside a node group, I don't think I can access... No attributes? Where are you talking about? Oh, because there was nothing in there. Oh no, we can get the ID. I keep forgetting. And also here, I should do the same thing. Where we get the index, and then we get the scene time. And then we get all that. Oh, let me read the chat again. So sorry, everyone. Let's see, just make sure this FDF node group, I already read that. Hope you have a nice end of the year. Thank you. I just joined. Is this going to make use of volumes for simulation in any way? No, volume sims are still a little bit in their early days. While it is possible to do volume simulation, it's not exactly the best idea. At least I haven't figured it out properly. So I'm just leaving that for the time being. Let's see. How do you fix the square shape of the random value? Yes, let's do that now. That was my next thing on the list. We are at 43 minutes. I will have to wrap up soon. Yeah, I gotta wrap up soon. And also let's turn on, because we have a unique ID for everything, it should make it so that motion blur actually works correctly. Because, well, the particles need to know if they're unique. And I'm pretty sure that set ID does that. Where if I didn't have that, if new particles were to join, especially out of order, the previous frame's position would go and have conflicts, and it would be very annoying to work with. Okay, so fixing the random value. So this is square currently. And actually, wait a minute. We have groups for that now, don't we? Utilities, rotation. I forget. I am in 5.0. Normals, utilities, vector. Here we go. Combined spherical. Now this, I believe... Sorry, I'm a bit at a loss for words right now. Because they used the legacy vector rotate node in here. I'm quite surprised that they did that. I thought that one was supposed to be, it's like, that node is like soft deprecated. For those of you who don't know, there is the rotate vector node and the, vector rotate node. And if you're wondering why these two exist, it's because one's old and one's new. One uses the rotation socket, one uses just the regular sockets. This one has more options, so some people like it a bit better. But this one, I do like its simplicity. While with this one, you would need to use like the axis angle to rotation and all that. One is just more of like a utility node, one is more like a user-friendly node. But one is compatible in the shader editor, which is why I think it's still around, one isn't. But it was kind of implied when this one came out that this one would be deprecated, but that was a long time ago, maybe even over a year. I was just a little bit surprised that the one that is kind of soft, you know, taking a backseat is being used in the official asset. That is quite interesting. I will go with the non-node group version here. Just go with, I guess, the raw math. Could I do it a little bit better in this case? Okay, well, anyway. Here, we'll just be using two random values. One for... This is probably inefficient. How do I make this more efficient? Like, I could always normalize this value, but then it would still be square and all that. If I were to use a sine and cosine, do I just try to do this in a raw math value? If I get the sine and cosine, and then the sine of cosine, and then do all that, it would be annoying to work with. So no, I'm not going to do that. I'm going to do this a simple way. So, I can use a combine XYZ to, here, let's go and chop that out from here. We don't need U anymore. We just need to offset the seed value because the ID is unique for all of these. And for here, I'm just going to set U to be unique there as well. So here, we'll plug this into the Z. It doesn't really matter which axis we use. It just has to be an axis for here. And then this for here. Spin that around. So with that, just with that, we have our rotation, which just needs to be a high value just to randomize it enough. And then this will be our amplitude, I guess. So if we do that into there, we should see nothing happens. Why? We have that there. That should be correct. Set this to 0.01. Oh, Oh, it's because, like a idiot, I forgot the order of operations. You want to set the ID after you duplicate everything. After. That's the important part. And I will use the scene time frame, even though I should set the ID for the main particles. I completely forgot about that. Just the order was very, very incorrect on that front. Okay, and that's good. Good. Okay, so now you should see, let's go and bump that up. Do you need Euler to rotation here? No, it automatically converts. There, in geometry nodes, there are some implicit conversions. And where they don't exist, it will tell you. Like if I had a matrix multiplication thing or invert matrix, we will see it will complain. Conversion is not supported. Vector to matrix. But here, the Euler to quaternion is handled. So it'll just treat it like an Euler and then just convert it to a quaternion. It's fine. If it doesn't complain, it doesn't complain. The devs were smart about that. And yeah, you will be informed if things go bad with all that. So here we have our amount. We can see that it's good. If I set it to be just 10, we can see that We have a very regular radius for all that. But we don't necessarily want that. I want that to be between like 3 and 30. That's a bit much. Yeah, that seems to be okay. We have all that. I am still annoyed that the particles... I could still make it so that I use the hit normal to make it so that they kind of reflect. But I do kind of like the circular parts. I think that's fine. I think we just need more particles. I think that's the thing here. 10,000 particles, potentially. There we go. That seems to be good. Lovely. Lovely. Also, maybe I'll just have a little pre-simulation step so that I can just set the position. Well, I would need to feed the scene, sorry, my brain just stopped working for a second. Let's also change the order here so that we can have the non-complicated stuff happening here and then all that happening in post. Or after. You know what I mean. We would need the delta time in order to do like a pre-simulation offset because I don't really like how this just goes from that to small and then it turns into that. It just compresses a bit too much. So if I just set the positions normally that, or I could just do this. Yeah, it'll be fine. I'll just scale it down by a lot. Instead of using delta time, I'm just gonna say, you know what? Just gonna do that. It'll be fine. So we can see, because of that, we're getting some artifacts here because the collision is not smooth enough. And these are being projected inside of the thing. So I'm just gonna mute that for now. I'll keep it around just in case. Let's go and save. Because this project is actually going pretty well. It's having a few hiccups just because I am quite rusty with all this. Again, it's the end of the year and I've done, I think, a record low amount of Blender this year, which I'm actually pretty happy about. And there we go. We can see that all that is happening. I still want the stuff to just stick and not fall. So, I think once it hits, I'm just gonna freeze them. Yeah, I think that's what's going to happen. So, this is going to be a little bit stupid. I'm going to make it a special scenario, or if there is a hit, and if it's not apparent, it will just permanently set this to be true. So we'll plug this into the selection, not the value. So that will just set it to be that and it'll be locked. And of course it did nothing. Ashishima. If it's not apparent and it hits, which that should already be true, it'll just set that to be permanently true. Oh, no, wait. This, I keep forgetting that actually keeps resetting it. We need to override this value. We're overriding the hit value. So, if there was a hit, or wait a minute. I could... If it's not apparent, I need to disable, I need to switch. I can compress the logic later. Let's just get this working. So again, we'll switch between that version of the hit or it just being true. And I'll constantly... Wait, why is this hurting my brain? If it's not apparent... is hit was true. It'll be there. But no, the main functionality changes with it being apparent. So, if it's the parent, it'll do everything normally. If it's not apparent, and if it hit in the past... Why is this hurting my brain? Maybe it should just be that. It'll only do that. It was true. Oh yeah, no, wait. I think that's the way to do it. Nope, it just phases completely through. And I need to switch for this. Wow, this is hurting my brain for some reason. Okay, so if it's apparent, I'll just switch it to true. So there we go. And nope, nothing happens still. If it's not the parent, that means it'll be true. If it hit, that'll be true. No, I need that to be false. So, yeah, okay. Need to invert this value. I will simplify this, but I think I'm... If you hit the previous frame, if you're not a parent... Maybe I just need to do both of these as knots, and that'll be fine. Nope. Why is this hurting my brain? Okay, let's go and chop that out for now. Maybe it's fine that it does just slide down, but I should know how to do this. So if parent is false, I can freeze it. So if I just have that as not, let's go and reset this. Sorry that this is taking so long. If there's no hit, and if it's not apparent, it will continue. Or it'll do a collision detection. So, should that be an or an and? Let's make that an and. Nope, and then we need to invert that part. I think it's the inversion that is... What the heck? That's detecting that, and then it's... I am going to just not do that right now. My brain apparently cannot handle it at the moment. But for what we have right now, this is fine. And now I just think I need to make good snow particles and all that, even though the point cloud is working just fine. It does spare on the instance handling. If I just have... Yeah, as a point cloud. And motion blur will make it so that you can't even tell the difference. Yeah, that'll be fine. So let's go and set the material. Won't even need to instance this time around. That is lovely. It should store a random value. Let's see. Just back from AFK. So do you use field space, F-space fields for low, or is this volumes or a handmade NPM? Nothing fancy here, mod. It is literally just getting SDF collision using this setup. Again, the normal here is simply to tell if we're inside or outside the mesh, and then we have to calculate the distance from the proximity because of reasons. Doing it the other way led to a curved sign distance field, which was not good. And then we are simply doing a very simple collision response. Snow flow. No, the snow flowing down, that is just an artifact of the collision. Because, with the way that this works, because there is a radius here, it collides, moves it outside a little bit, then it moves it down, So, gravity is causing to do that. The radius plus the gravity makes it slide down. So it is technically an artifact, but one that I don't really know how to fix. And if you're wondering about this artifact right here, it's just a result of that. There being just faces here because it collides with the actual surface, not with a fake it, you know, the actual geometry. If I turn up the subdivisions, we can see that it becomes less of an issue. So now we have that. We have the snowballs doing all that. The snow will not accumulate because I don't really want to do self-collisions here. I could, but kind of don't want to. Also, I think I need to make the snowballs a little bit smaller. Let's put this at 0.175, and that'll be good. There we go. So now we have all of that. That seems to be good. I could throw the snowballs faster. That could be nice. Let's also make our guy over here. Oh, you're an asset. Right. Dang. Okay, let's just... How do we do this again? Do I... Does that free up? Nope, it doesn't free up everything. Object. That. Okay, I think that freed up everything. I still need to figure out the new, like, assets with the deduplication and everything. But, that's fine. Let's see. Yeah. But we can see here the particles on the ground are fully stable. Not doing the little bouncy thing that can happen with some collision things and all that. Now, because this is SDF collision, and this mesh is just one face, we can see that they pull up on the sides and will not cross over because they'll technically be leaving their allowed play area if I were to add in a solidify. Also, another thing, if the mesh is too thin, they will clip through, of course, because that's where you would need simulation sub-steps, which if I were to do that here, all I would need to do is wrap this inside of a repeat zone, probably before, or no, after the join geometry, because I don't want it to join multiple times, and then I would have to divide the delta time by the amount of iterations. Now, there is a way, using delta time to make the fire rate work the way it should, though I keep forgetting what that is. I think it would need me to store the delta time on this one particle or have a counter between the previous firing thing, but I don't want to do that. That would need probably just a constant value that would increment every single time, and I don't want to pass a value through there. It should be fine. No closures on the sim. No, I'm keeping this simple this time. Keeping it simple this time. Yeah, just again, for this end of the year project, looking back at all the things I've made this year, all the things I've done, I kind of want to just do something simple today. Or simple in the grand scheme of things, something that I've done quite a few times. But yeah, maybe I should randomize the snowball throwing angle. And to do this, I just need to add to the vector rotation here. So let's make this a random value, of course. Random value, vector, do that here and there. That to be -1, scale, use the scene time. I should use, again, yeah, no, I'm going to do that now. Let's see, set ID, we're going to just hash this. Hash value. Even though I should do this beforehand because I'll be using a random value. Yeah, let's do that second. Oh wait, it's gonna be in the I keep forgetting if there's a remove this from the node link kind of operation and all that fun stuff. But with that, we just need to put the scene time frame into there, into the seed value. Now the thing is hopefully. And the index is just 0, but I will put this into there just because. So that should make it so that we don't need to plug that into every single one of these. All these will have a unique random value to all of them, in theory. Yep, that is to the frame. Let me just collapse all this into a nice little thing there. So since it'll have a unique integer value for every single one, that should be perfectly fine. We plug that into there, into there, into there. Collapse that, plug that into there, set the seed value to be something high, even though it doesn't really matter at this early stage. But now, as we should see, hopefully, please, for the love of all that is... to connect it. That would explain it. Here we can see that the particles are being thrown in every which direction. And this is in radians, so let's do 0.25. 0.25. Here we go. I just want this to be a little bit different, to have a little bit of a random value going. And let's change the interval here to be 5. So every 5 frames, it'll go boom, 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 boom. There we go. That's pretty good. And also, we don't need any manual animation here, so I'm just going to delete all of that. Bring this over to here, maybe angle it up a little bit so we can have our little snowball. Whoa. Did that one just tunnel through? Okay, I'm going to disable this solidify there, just so that I can have boom, 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 boom. Lovely, isn't it? Oh, and some of the particles are falling because this is a perfectly vertical surface. That is actually hilarious. But there we go. Not bad. I'm happy with that. Took a little while, but we got it. Eventually. Let's go and make it a little bit. Now, I could make it so that I use... So with this, since it's random, we're getting a very spherical shape. But I could make it so that this looks at least a little bit more random using a noise texture. Let me go and demonstrate what I mean right here. So, right here we need to feed in a value. Let's see, how do I put this correctly? This will be, let's see. So I'm going to make this a bit better. So here we have a random vector rotation. We're going to make this 1. And this will treat as our position for the vector here. And then we're going to scale our position, or yeah. This is a sphere with a radius of 1. And that will feed into our position for the noise texture. And then we'll multiply this by, say, a map range. I should randomize this per the previous ID, but it'll be fine. Or I could use the main position to randomize it. Oh yeah, that could work. Long story short, I will use this to get a still random feeling snow distribution, but we should see it has more of a pattern. Let me go and turn that up by quite a bit. But there we go. We can see that it has much more of a pattern here. There we go. Yeah, see, look at that. It still feels random, but we can see that there is a noisy distribution of everything. And if I wanted to make it a little bit more random so that it doesn't have the same kind of noise feed, I guess, we can just move the position according to a hashed its current position. Because again, the actual position of the point is where the parent landed, and the children have not moved yet. So we'll take this, hash the value. Oh, that may be a really, really dumb idea, if I'm being honest. Because that may lead to float point precision errors, which is probably a really bad idea. Though I could just feed it into random value and then offset it from that. So it is a bit of a workaround. Or I could just multiply the position value by a lot and then put it into there. But I don't want two snowballs that hit very close to each other to have the same. You know what? It's fine. It is completely fine to do it this way. It's fine. You don't need to make everything 100% mathematically accurate. That's how I got very frustrated with trying to make particle collisions. It doesn't need to be like that. It is completely fine. As we can see, the particles are being thrown. All that's happening. It is quite good. We can change the scale so that we can get, yeah, as we can see, still a very different thing there. I can turn up the detail so that it is a little bit more rough. It still has a general shape, but, yeah. Now, it does seem to have... The volume isn't quite there. it seems to be just like a shell that explodes. I could just multiply the effectiveness here by random value to make it appear a bit better. But again, as we can see here, yeah, we can see this kind of shell. Not the biggest fan of that. And I can either... Yeah, let's just multiply that by a random value. So it'll be between 10 and 0. So, yeah, there we go. It still has a general shape, but still feels like it has the volume. There we go. If one geometry doesn't have an ID attribute, and the others have, the joint geometry must generate new IDs for the part without them. Ah, thank you. Yeah, that's one. IDs, I still haven't looked into the code for that, so I don't fully know how it works. I'm just inferring from, like, notes the developers have made, and also other programs. I think Houdini, I forget how Houdini does the ID, it's been a while, but the general vibe I remember is that the ID is essential for a lot of that. I'm going to just go and chop out that part right there because it's not necessary anymore. So this will be our Snowball's explosion thingy-mabopper. I still want to freeze the particles, and I think that'll be the last thing I do for this. Let's go. Ah, we can see the very nice halo from the reflections there on EV Next. EV Next has been an interesting talking point recently. Some of the community has expressed their very colorfully worded frustration with EV Next, and a lot of people responded to that. But also, even the developers have mentioned that EV Next has had an interesting development. For me personally, I guess this is just, you know, just a theme with it. The noise and also the blurring of the said noise is the main thing keeping me back. It is still functional, like I still use EV Next for quite a few of my projects, but for, I'd say about, I don't know, a quarter to half of my projects I still use 4.1 EV Legacy, just because it's still, the quality is not the same as EV Legacy. And I could go into detail with that, but the devs already know about that. EV Next is already fast. That is, yes, that is 5.0 with Vulkan and all that. Shader compilation is faster than EV Legacy, which I do very much appreciate. EV Next does have its upsides. The downsides are just with their ray tracing and noise algorithms for the shadows and all that. As we can see here, metals suffer greatly compared to EV Legacy. This is a very... It can be quite a blurry mess. And also, this is with bilateral filter off. If it's on, all of these lines here get blurred because it is just a bilateral filter. Yeah, it's can be a bit rough at times. But yeah, metals suffer the worst from it. Okay. But I don't want to harp on EV Next all too much. People online have done more than enough with all that. Let's go and change the motion blur. No, I think the motion blur is actually fine. I don't think we need multiple steps. Let me go and save this and then render a frame. As we can see, that's quite fast. And we can see, yeah, that works pretty well. If I were to render this, I think it would turn out well. With the lighting, though, oh, let me go and join up because I don't need to do that anymore. In the compositing, we don't need to do anything there. I want to go into the shader, need to go into the world. With the snow, I don't think it needs a shader. I think it's fine as is. Wait, it has a material, right? But we're getting a... myself. Join geometry node doesn't make the rest of the IDs. Ah, that is interesting. For my previous particle system, when I made it like 2 years ago. Damn, it's been 2 years ago. It's been a long time. I've been doing this for so long. Is camera ray, that's what I was going to do, so I can just change the world background color. There we go, that's pretty good. I want to increase the contrast with all this Let's go in. And also another thing with Eevee Next, this weird color banding never existed in Eevee Legacy. It's only in Next. And I assume that they just changed the way colors work where there are not enough colors to go around in the dark shades. But this is extremely apparent. And this is another thing that's made me not want to work with Eevee Next all too much, if I'm being honest. It just feels like with the Eevee Next, it took a lot longer. It took a long time to develop, 2 years longer than they expected. And the result, the visual results, well, on a technical level, apparently it is better. Like, the compilation times have gotten better now that Vulcan is actually in. That took another year. But the visual quality has regressed a fair bit. I'm not sure if you can see this color banding on YouTube, but it is extremely apparent to me. And the more you bring this down, the more apparent it becomes. And as far as I know, you can't avoid it. It's just a matter of there aren't enough colors to go around, where Eevee Legacy did not have this problem. This is for me personally, this is a breaking issue where I would not render if this was a problem. This just shouldn't be here. And that is, again, one of the things that makes me not want to use Eevee Next. Again, I feel like this could be fixed just one update away, and the developers are getting to the user-facing issues with all that. But up until, like, recently, it feels like most of the work was being done under the hood because apparently a lot of things were, needed work. And this, so this is happening when the working space is Aces? No, it's any. This doesn't happen with Cycles. This would not happen with Eevee Legacy because projects I would work in there, when I would update them, they would have issues. The glass colors have changed with Eevee Next versus Legacy. There's just quite a few issues where Eevee Legacy still looks better in many situations. For the shadows, to make it more like Eevee Legacy, turn on jittered shadows, which you have to do for every single light, which is very annoying. And there's still noise, but this gives a more accurate result with larger shadow or larger lights where you don't get tons and tons of light leaking. I could make a whole video about Eevee Next versus Legacy, about things that they could improve. And the devs do want to improve it. I'm not knocking the devs. But since Eevee Legacy versus Next has become a very heated talking point recently, I just want to put in my input without being too annoying about it. Even though I have mentioned quite often this past year. But yeah, it is, Eevee Next just needs more time to mature. Let's see, let's go back to the object space. But yeah, let's talk about the good things about this year. Eevee Next, again, just needs more time to cook. Geometry Nodes has had many very good improvements. From a year ago to now, it has improved so much. Actually, let me just check. Let's see, Blender 4.1 release date. Oh no, 4.1 was in 2024. Okay. When did 4.2 come out? 4.2 was last year? About a year and a half ago? Oh, so Eevee Next has been, it had a 2-year delay, was released in 4.2, and now has had a year and a half to cook in major Blender releases. Okay, when did 4.4 come out? Okay, so 4.4 came out in 2025. 4.3 was November 2024. Okay, so we went from, again, oh yeah, 3 updates this year. We had 4.4, 4.5, and 5.0. So a lot of cool things happened. And I just need to double check. Release notes. Let's take a look at geometry nodes because that is my bread and butter. Basically all my work, all my major work is, where are the change logs? Okay. Yeah, let's do at least as a summary. I still have time, right? We're at an hour, I think. Oh, an hour and 19 minutes. Yeah, let's go and finish this up. I will need to make this pretty and everything, but for a simple snowball simulation, it's fine. It works. Nice little thing to cap off the year. Oh, I think that snowball is still comically too big. Let me reduce that to 1.25. 0.125. See, is that a little more reasonable? Yeah, that's a bit better. That is, yeah, that's a lot better. Even though I think I need to restrain the range of these particles. Let's set it to be, yeah, just a constant value. And we didn't even need the seed. Actually, no, we did need the seed for that. Let's see, what feels right? Nope. Let's put that to be 4,000. Could be a few more if I want to be a greedy bugger, but, yeah, no, that's fine. Yeah, that seems to be good. And then with actually calculating the motion blur, it'll be pretty good. Even though it still annoys me that that happens, so let me go and turn back on. Just make it a little bit bigger. Just so that it's... yeah, just a little bit better. Yeah, that's good. Okay. Anyway, let's go and make this a lot more reflective. Does that? No, that makes it look worse. Maybe it just needs a different color. Brighter color. That color. Oh, that looks nice. Feels kind of Christmassy right there, even though it does kind of overpower the snow. Eh, it's fine. Bright colors are better. Okay, let's take a look at 4.4, because that happened this year. Geometry nodes. All that. Maybe I should... okay. So 4.4 was a fairly small release in terms of geometry node stuff. Let's see. Again, that was after 4.3, which was pretty big if I remember correctly. There was the... let's see. Collection and object input nodes. Yeah. Here, let me actually go and share part of the screen. Let's see. Forget how to do that. Capture. Let's go to the right one. Nope, that is not the correct one. Ah, there we go. Okay. Yeah, I just need to make sure really quick that I do not leak anything. So please bear with me. Firefox. Yeah, Firefox will work quite well. There we go. That's a bit better. Sorry for the delay, everyone. Okay, turn off studio mode. Okay, now you can see that, right? There we go. Okay, so 4.4, fairly small release. A few a few input nodes, which is always nice to have. The find and string node, which is very nice for parsing files and stuff like that. Point geometry and realize instances now preserve the vertex group status of the input attributes. Ah, yes. Vertex groups, that's one of the things that I really want to see change in 2026. Because vertex groups are still a bit awkward to work with geometry nodes. Because they're point flow attributes, but they're still considered a bit different. They're still a bit quirky and everything. We cannot create them with geometry nodes, but we can convert them into regular flow attributes and all of that. So that's still a point where geometry nodes can't reach. So that's on my list. Let's see. Text overlay works with matrix attributes now. That's nice. Performance. Oh, a 30 to 100 times performance improvement on the triangulate node. Oh, I was very happy when I saw this. Because for a certain high-profile project, I needed to use the triangulate node. And that was very, very slow when I was working with it. This part is streaming, right? Yeah. Let's see. And that performance improvement was very nice. And then sort elements got 50% faster, which I assume is because it's a sorting algorithm and they switched it up a little bit. Maybe multi-threaded it, I'm not sure. And then the warning nodes are very nice for the UI parts. And I think that was the main theme with geometry nodes for 2025. Making node groups more powerful and have better UI stuff in preparation for assets, which arrived in 5.0 and will become much more powerful in 5.1 if everything goes according to plan. Let's see, Blender 4.5 LTS. So here we got the mesh normals, which people have been waiting for a long time, and we got them. And they were very, very nice. It could be used for all kinds of things, basically to make I have used this in my work where it's like, oh dang, the what is it? I forget what the modifier is that deals with mesh normals, but the other one didn't really work the way I wanted it to. So I literally was just like vertex group this part, this part, this part, and then assigned them almost manually, and it worked so well. So that is one of my favorite nodes from this year. The import nodes, I'm so happy with these as well. Basically, dare I say, making Blender a little bit more like Houdini, where it's just like, oh, you can bring those parts into here, all that happens. The CSV node, oh, when string attributes become a thing, that needs to update. Because right now, that cannot handle string attributes, which CSVs have a lot of those. So I'm making a mental note of that right now. I think maybe I could implement that when string attributes and lists are implemented. I'm not sure, but I need to keep that in mind. I'm planning for 2026 already. We got import obj, stl, ply. People have used that for the Gaussian splats, which we took a look at this year. Import text, which will become very useful even in the future when more text-based assets come around. Because of the font socket, which may come in 5.1, we'll see about that. And then files can be dropped directly into geometry nodes, which is very nice. Love to see that. And then the format string node. Always love to see that. Grease Pencil got some more stuff right here. I think this is, yeah, these were like the softness and stuff like that, and the order, I think, as well. Lots of other stuff. Visual geometry to objects. This one is very nice, basically making it so that instances that you make in geometry nodes can become real, and you can actually place them in your scene, and you don't need to export and then re-import them as an Alembic to make them real. Alembic or USD, I forget which one I used in the past to do that. And then more nodes. Oh, look at this. I wonder who helped make this one. The camera info node for camera calling and stuff like that. The devs helped a lot with this one because apparently this was a dependency graph nightmare, at least for me. But now we have it. This was also used for the Gaussian splat setup, so this is being used by people for a lot of very, very cool stuff. So I am so happy that made it in. And this will be used for official projects that I'll be working on in the future, but you'll probably see that in 2027. Let's see, attribute statistic. These are very, very nice. Oh, 4.5. Yeah, no, that was a big one. It was an LTS, so I'm very happy a lot of that got in. Attribute statistic, which is very appreciated. Oh, I could use that with my separating axis theorem setup. If I ever make it work on instances and stuff like that. Format string. Yes, they got a syntax compatible with Python and path templates. Very, very nice. The function node, or wait, no, not the function, the expression node feels like it'll be following in these footsteps if it comes in 5.1. We'll see about that. Node tool UI getting redo panel. Panels and attribute search. Yes, that's very nice. Again, making node groups, I count node tools as node groups, more powerful, which is very nice. And then a lot of other stuff over here. So that happened. Let's see. That got a bit faster. Oh, that's pretty good. And then that's 4.5. And then 5.0 I don't think I did anything in here. Forget if I did, but let's go over this once again. 5.0 was a big one, where we got bundles, closures, which those will be very, very useful. They are useful now and will be very useful in the future. And another thing I want to note, some people have said, oh, geometry nodes has gotten too much attention, which I do understand that geometry nodes has gotten a lot of attention. It is one of the most powerful parts of Blender nowadays, and that is because I use it all the time. But a lot of these features have spilled over into the shader nodes because those have needed updates. So bundles and closures both were added to the shader editor, and that's also paving the way for shader editor node groups to become much more powerful, with maybe potentially a texture socket in the future, maybe in 5.1. We will see. Lots of stuff is being tested, but geometry node stuff is paving the way for many other parts of Blender to be updated. So yes, those are also available in the shader nodes. Many people are very happy about the closures because now in the shader editor they could input textures for like complicated stuff like parallax. There was like parallax, there was like scattering with accurate blending without having to rely on hashes. All kinds of projects that would use textures, where now they don't need to go inside the node group and change every single one. So closures people have been loving them in the shader editor. Yes. And then volumes, many volume nodes, many volume nodes, which those were implemented very close to the 5.0 deadline. But oh, sorry, my voice is going. What was I saying? These are mostly ported from OpenVDB. So a lot of them were able to squeak in at the end of the thing there, which was very nice. Lots of stuff there. Most of these were done by Brady, I believe. I'm forgetting his last name. Actually, wait, I can look at the blog post. Let me make sure that this is still, yeah, that's still going correctly. Let's see. I'm forgetting where the .org. Let's see. Brady Johnston. Yes. Did a lot of work on that, which I'm so happy about. I should have full screen this, shouldn't I? Yeah, there we go. That looks a lot better. There we go. Sorry about that. Let's see. All that. Yes, the volume nodes are very appreciated. UV tangents! Now, those of you who have been around this place for a long time have known that like 2 years ago, I made my own UV tangent node, which is fairly accurate, but not the most accurate. And now we have a native UV tangent node that is one-to-one with the shader editor, which is very nice. And then some essential assets, which is very cool. Again, we took a look at these. And then, oh, random rotation. That's what I should have used. Instead of, wait. I need to take a look at that right now. I want to take a look at the internals. 1 second, everyone, as we go back to the main thing here. Random rotation. How did I miss that? Random rotation. Let's take a look inside. What's it using? Ah, okay. A lot of stuff. And then quaternion. Ah, okay. There we go. Yeah. There we go. Yep. So that's what I should have used. Then, yeah. Let's see. So away from the Z plus direction, and then that. And then I could just convert that into... Yeah, I could use that to rotate a vector and scale and all that. Yeah, no, that's all good. I forgot about that, dang. There we go. And then string to value node, which many people have wanted. That just helps with dealing with different values and stuff like that, parsing text and everything. And a few more options for that and that. Manage panel, you can now hide node groups. And then, let's see. And we're in 5.0 now. Yeah, we are. And then some fixes. menu sockets and all that. Again, node groups becoming more powerful and everything like that. And then better text displays for all that. And the ID attribute is now generic. Ah, that explains why I forgot that it was a generic attribute, because I've been spending so much time in 4.1 still. Yes, and then warning stuff, and then viewer notes, and all that cool stuff. Let's see. I already made a Voronoi node group for shader-based closures and bundles. That is interesting. Though, I do fear Voronoi is the most expensive node, and I assume a hard-coded version versus a node-based version would be quite expensive. Though, it's very cool to see that that's even possible with the closures and such. I am very happy that closures made it into both, because they are extremely powerful, and will become even more powerful if some things make it into 5.1. And speaking about Blender 5.1, let's take a little look into the future. There should be basically nothing in here. Yeah, not too much happening in there just yet. Though, the bone info node, and then, let's see, Pack UV Islands and all that. 5.0, I have, 5.1, I have many plans for, as, we saw in, let's see, 5.0. I don't think I got anything into 5.0, besides the, wait a second. In 5.0, did I forget? There was the geometry attribute constraints. Let's take a look at the manual instead. There we go. Basically, well, I've gone over this. I made a whole video with that. Yeah. I think this took the longest to work on because the constraint system is absolutely ancient. But I'm happy this got into there. This is tangential to geometry nodes because I made it so that I could use geometry nodes. Many people have used this, and I'm so happy for like add-ons and stuff like that to basically make rigging nodes and stuff like that. So just a little extra layer of communication between geometry nodes and real objects, bones, and stuff like that. People have done so much with it, and you don't need to use geometry nodes with it. It's just data on geometry. So that is very, very powerful. People have really used it, and it just opened up a whole new world for some people. Where before, you could kind of do this with constraints, but you would need multiple ones, and I don't think you would be able to do like sharing data with matrices, but now you can. So, whole new layer. Blender has, over the past year, has gotten a lot better with dealing with data types and stuff like that. Again, matrix attributes were introduced in 2024. Yeah, in 4.2. So those have been around for a while. But now they're just being available in more areas of Blender. So, 2025 was very good in many, many aspects. But for Blender, Eevee Next is maturing. Geometry Nodes has gotten a lot of cool stuff. Some stuff that I never thought would be available in that I didn't think would be possible. And 2026 is on track to be even better. Even better, because a lot of the setup that happened in 2025 will be paying off in 2026 as well. So Blender has gotten a lot better over the past year, and that is just on the geometry node side. Not even talking about the rest of Blender, which apparently the people over there are very, very happy with all that. I forget when the Ray Portal node came around, but that was a big one. People are using that. There might be a Raycast node in the future, which will be like a generalized Ray Portal node, and potentially more powerful. I do want to play around with that. But yeah, in summary, lots of cool stuff happened this year. And we'll see what 2020, I'm getting tired. We'll see what 2026 brings. I probably won't do as much in Blender as this year. I'll be probably working a bit more on very, very cool stuff that you'll probably see in 2027. But I feel like, for me personally, at the very least, I feel like I've done almost everything I wanted to do in Blender. Like, I've been doing particle systems for 2 years now. I've been doing a lot of other procedural stuff. And I feel like my R&D work in Blender is still going, but just my general projects, I feel like I've done almost everything I've wanted to. So now I'll be working more behind the scenes on hopefully making nodes and giving feedback on stuff like that. So we'll see. We'll see what goes on. Let me read the chat again. I forgot to check if it... Oh, the Voronoi group has native loops. Yeah, that is, that's something I was thinking about. That and the node limit. Because again, Voronoi is expensive. And it's interesting because since node groups are becoming so much more powerful, it makes me think about the native versus the hard-coded versus the node group approach to things. Because there is still a node limit in the shader editor. And also with node groups, there will be a not insignificant amount of overhead. So there is still a place for hard-coded nodes and stuff like that. But the more powerful node groups become, the better. Because that means that little Timmy will not have to open up Blender source code to have to add in functionality that they want. So that'll be good. But yes. Quite a cool snowball simulation right here. Again, it is just the most basic collision detection and the most basic particle splitting and stuff like that. Particle systems may become super powerful in 5.1 using the new closure tech that may be coming around. But we will see about that. We will see. But yes, thank you all for watching. I hope you all enjoyed. Get your last questions in now before I head out for the day. And for probably the next couple of weeks, I would assume. I'll probably not be doing too much forward-facing Blender stuff for a while. Yes. Let's see. The geometry attribute plus bone info is going to be an unstoppable combo. It will be very interesting. Yes, that will be a very interesting setup. It will need a duplicate armature because, well, we don't have proper, like node-based constraint and stuff like that. So you would need to have one armature as the main, and then a puppet armature that's being driven by geometry nodes. So you would need two, but it'll work. But that's something I'm interested in the new year. About a year ago, almost to the day, I was working with geometry nodes rigs in a sense, but they would only work inside of geometry nodes because they couldn't access outside bone information. So they would work, but just not, they were incompatible with like getting data from other places. So that's something in 2026 I want to do. I want to make it so that geometry nodes can actually read what attributes are on geometry, because currently it can't. Like right now, if this has a ton of vertex groups or UV maps and stuff like that, you can't dynamically look through and access all of these. You would have to put them in manually, which is very, it's a slowdown when working with geometry node based rig dynamics. One of the developers has run into that. And I've ran into that personally a year ago, a little over a year ago now. So that'll be a cool thing to implement. I was waiting on lists and string lists specifically. And since those may be around in 5.1, we'll see. It's never guaranteed, but that may come around. And then getting the armature, we don't even need the armature bone list because the vertex groups will tell us which bones exist on a piece of geometry, or related to a piece of geometry. But yes, many cool things. Lists will be a main theme of 2026, and that'll lead to a lot of many cool things. So yeah, the theme of 2025 was maturing the node groups and just general functionality of node groups and assets in Blender, at least on the geometry node and shader node side. Again, bundles and closures were a major part of that. Node group UIs getting more menu sockets and stuff like that. And then 2026, I think, will be maturing even more, and we'll be seeing a lot more with that. So, a lot of cool stuff will be happening. And also Blender being adopted, like 2024 Uh, a lot of major stuff happened there. Let's see. Again, Sonic 3 came out basically almost a year ago today. Even though, yeah, it technically happened in 2024, but that was Christmas 2024. And again, a good amount of that was made in Blender, and I had a hand in a lot of that. So that was a major, major thing. And then 2025 stuff happens that I can't talk about. And cool stuff will happen in 2026, and you'll probably see it in 2027. So yeah, the future of Blender is bright. Though it's been very good. But yeah. Forgot what else I was going to say about that. But I've been yapping for a bit too long. We're at an hour and 45 minutes. I've been talking for too long. But it's the end of the year. I can yap as much as I want. But yes, in terms of all that, I may be doing less Blender stuff overall because I've done almost all that I've wanted to do in terms of projects, and I wanted to go and do more stuff in real life. The main theme for me this year was going out and just going to more events IRL. Whether it be like related to 3D motion graphics, like I've been going to New York, and that's been very nice. There are a lot of motion graphics and 3D art people over there, and it's been nice talking to them in real life. Not to knock like the online groups I've been talking to. Those are very nice, but going to events where there's like a giant 30-foot LED screen where people are doing Houdini stuff, that's very cool. Got to meet many cool people who inspired me when I was younger. The guy who worked on the Westworld intro. I also got to shake Andrew Kramer's hand, which I'm not in the like Adobe After Effects world, but that was cool to see. But I got to see so many cool people, little celebrities in the 3D art sphere. Also got to meet with Curtis Holt this past year, who went to London just on a whim. It was a magical time because it was sunny the entire time in London, which does not happen apparently. But that was very cool. So I would say, in summary, Blender has given me a lot, and now I want to see what kind of... I want to explore more stuff in the real world, since Blender for me has been very isolated to the digital world. So I want to see what kinds of 3D and motion graphics stuff I can explore in the real world. And we'll see what form that takes. So, yapping session pretty much over. I hope you all have a wonderful time. I'll read the chat one more time. And let's see. See you, Caramel. Wish you a Happy New Year. Happy New Year, everyone. I hope you had a wonderful holiday. Let's see. I'll be looking forward to your import CSV stream once it can output strings. Yes, that will be interesting to see. Very excited to see where Blender is going and what you'll show us in the future. Will people catch you at the next Blender conference? That is the plan. My plan is to go to the Blender conference. Unfortunately, this year, due to work, I could not make it, which was very funny. A lot of the stuff in my work will probably be, well... Actually, yeah, no, that happened this year. This year at the Blender conference, my supervisor, one of my supervisors, presented about the work on Sonic 3 and gave me a shout out there. Which, wait, I forgot to write that down in my year summary notes. Dang. But that was one of the showcases of, like, you know, I should have been there this year. I really should have. It is fairly ironic that my work was being shown at Blender conference, but that work in and of itself was keeping me from going to the Blender conference. That very ironic right there. But I will make sure, probably, most likely, that I will be at the Blender conference this year. Because I've been around, I've talked with many of the Blender developers, many of them follow me, and it's about time that I meet all of them. Because I've met several people who have met the devs, Curtis and several other people I've met in real life. It's like, yeah, no, it's about time I go and say hi to them in person and meet all of the amazing Blender people over there in Europe. Because there are many Blender people that I am friends with over there in Europe. And I want to meet more of them in person. Because they are amazing people. They are amazing people. Yes, thank you all for watching. I'll see you all next time, sometime in 2026, but I'll probably be taking a bit of a break with all that, with streams and stuff like that. But I'll see you next time. Have a good rest of the year.